Chapter 4: Supply Chain Coordination and Use of Technology. Objectives: First, understand a common supply chain dynamic that is a major contributor to the boom-to-bust business cycle. Second, appreciate the factors that contribute to the supply chain dynamic. Third, evaluate ways to combat this dynamic. Fourth, assess the technology that is available to support and enable effective supply chain coordination. Introduction: The spread of high-speed data networks and advancement in computer technology have revolutionized supply chain management. Since the mid-1980s, companies have gained the ability to manage their supply chains with the precision that was previously unattainable. This technology enables the businesses to respond more quickly to changes in market demand, which has become a critical factor in competition. Companies that adopt modern supply chain techniques and technologies can gain a competitive edge. To succeed, both individual companies and supply chains must adapt by learning new strategies and implementing the right technologies. The bullwhip effect. The bullwhip effect refers to how small changes in consumer demand at the retail level cause increasingly larger fluctuation in demand as you move up the supply chain. Companies at different stages misinterpret market signals, leading to shortages followed by oversupply. This often results in excessive inventory, wasted production capacity, and financial losses. In short, the bullwhip effect is a misalignment between actual consumer demand and the supply chain response to that demand. Product demand distortion swings. Inventory levels in a supply chain can fluctuate dramatically due to the bullwhip effect, where distortions in product demand are amplified as they move from customer to retailers, distributors, and manufacturers. Companies further up the supply chain perceive these swings more intensely, complicating effective management. Example: Initial demand. The hotel experiences a slight increase in guest bookings during a holiday weekend, leading to more guests dining at the restaurant. Restaurant reaction will be anticipating continued high demand. The restaurant orders larger quantities of ingredients from its food supplier. Then the supplier response will be the food supplier seeing the larger order, increase its own order to farmers and manufacturers, assuming demand will keep rising. Then the result will be when guest numbers drop after the holiday, the restaurant has excess food, and the supplier is left with surplus stock, leading to waste and financial loss. This shows how small changes in guest demand can ripple through the supply chain, leading to overordering and inefficiency. And here's other example.
What is the bullwhip effect? The ripple effect of small changes in customer demand are magnified upstream through a supply chain, all the way from the customers, to the retailer, to the distributor, to the manufacturer. So named because of the resemblance to a bullwhip, as the variability of demand increases sharply when you progress up the supply chain. For example, John has friends and family staying with him for a few months and buys more coffee than usual. Then the local supermarket sees the increase in demand for coffee and increases their order size with the wholesaler to refill buffer stock. Then the wholesaler sees the increase in order from the retailer and places a larger than normal order with the manufacturer for projected increase in demand. Then the manufacturer produces more coffee based on projected demand. The results? The manufacturer overproduces coffee. The wholesaler stockpiles extra coffee, and the local store holds extra coffee and delays their next order.
No more orders today.
No thanks, we don't need any more orders.
And thus the manufacturer already has excess inventory and notices the reduced order, then scales back on production. Has this happened to you?
Coordination in the supply chain. Research into the bullwhip effect has identified 5 key factors that contribute to demand swings in supply chains. These factors interact in various combinations, creating challenges for efficient management. Understanding and addressing this factor is crucial for coordinating supply chain actions. They are: First, demand forecasting. Orders affected by the bullwhip effect distort demand forecasts as companies rely on received orders instead of actual customer demand. This distortion worsens up the supply chain. To counter this, companies should share point of sales or POS data to align with real market demand. As companies move further up the chain, they risk losing touch with actual demand if they focus only on fulfilling immediate customer orders. For example, a retailer orders extra toilet paper due to a spike, and the supplier and manufacturer overproduce. Demand drops, leaving excess stock. Sharing real sales data could have prevented this. Order batching. Order batching occurs when companies place periodic orders in larger quantities to minimize processing and transportation costs, often following the economic order quantity or EOQ model. This leads to discrepancies between orders and actual demand, which are amplified up the supply chain. For example, a retailer orders in a bulk to save on shipping, causing the supplier to see irregular demand. The supplier then produces more, creating a mismatch between actual demand and supply up the chain. Third is product rationing. When manufacturers can't meet demand, they often ration products based on order quantities. For example, if they fulfill only 70% of orders, they allocate that percentage, prompting distributors to inflate their orders. This shortage gaming exaggerates demand. To combat this, manufacturers can use historical order patterns for rationing and inform customers about supply limitations to prevent panic buying. For example, a manufacturer fills only 70% of orders, so distributor overorder to get more stock. Distorting demand, clear limits, and using past order data can stop this. Fourth is product pricing. Product pricing fluctuation distort demand. Special sales can lead customers to buy more or purchase early, creating surges in demand that disrupt the supply chain. To address this, the concept of everyday low prices can help. If customer trust they will always get a good price, they will buy based on actual need, making demand easier to forecast and allowing for more efficient responses in the supply chain. For example, a holiday discount prompts customers to buy early, leading to a spike in demand that strains the supply chain. Adopting everyday low prices can stabilize demand and improve forecasting. Last is performance incentives. In a supply chain, companies often manage roles in isolation, leading to misaligned incentives. Sales teams may create artificial demand by pushing unnecessary products to meet quotas, while managers may prioritize cost savings over customer service. To address this, companies should align performance incentives with supply chain efficiency using active-based costing (ABC) to identify conflicts and costs. They can then experiment with new incentive plans that promote overall supply chain effectiveness. For example, a beverage company sales team pushes unnecessary promotions to hit quarterly goals, flooding the market with products that customers don't want. At the same time, the supply chain manager focuses solely on reducing costs, neglecting timely deliveries. The companies then analyze costs with activity-based costing and revises incentives structures to encourage collaborations, ensuring that sales efforts align with actual demand and efficient supply chain operations.
Alihaya Goya. The goals present the theory of contains TOC. TOC companies improve by identifying and managing the most material bottlenecks in their operation. By focusing effort on those contains, business can enhance efficiency and output. Example, a packaging company identify its labeling machine as the bottlenecks in production. To exploit it, they ensure the machine always has enough labels and materials to run continuously, and they then slow down other machines to match the speed of the labeling machine. And finally, they upgrade the labeling machine to increase its speed, boosting overall production. And the company followed the theory of constraints by the first identifying optimizing the slowest part of their process, then aligning everything else to its capacity, and finally improve it to enhance total output.
Flow of work inventory through a factory. Operation C&E are the bottlenecks in the factory, dictating the overall productivity. Improvements in other operations won't enhance factory productivity. To address the bullet effect, manage the supply chain as a unified entity synchronized to actual market demand. Sharing sales data and forecasts among supply chains participants allow better align with demand. Buffers in the supply chain should reflect demand, uncertainty, and required services levels. Lower uncertainty allows for smaller buffers. Companies can manage these buffers through productive capacity or inventory as needed. And here's the example of flow of work and inventory through a factory. From raw materials and components, then warehouse, production, quality check, then warehouse again, then finished product, then shipping.
Flow of inventory through a synchronized supply chain. The drum buffer rope model uses market demand as the system's constraint, setting the pace for the supply chain. Companies manage uncertainty with buffers of inventory and productive capacity, kept low by sharing market demand data. This data acts as the rope, enabling participants to synchronize their actions effectively. One of the applications of the theory of constraint is in production planning. Collaborative planning, forecasting, and replenishment. To improve supply chain coordination, the Voluntary Inter-Industry Commerce Standards VIC Group established a committee to explore collaborative planning, forecasting, and replenishment (CPFR). This committee documents best practices and creates guidelines for CPFR, which consists of three main activities: planning, forecasting, and replenishment, each with several steps. Collaborative planning: negotiate a front-end agreement outlining responsibilities. Develop a joint business plan to meet demand. Collaborative forecasting: create sales forecasts for all companies, identify and resolve exceptions for a common forecast. Collaborative replenishment: generate order forecasts for all companies, identify and resolve exceptions to create an efficient production and delivery schedule. Generate actual orders to meet customer demand. The, V- the VIC group has formed a committee to enhance supply chain coordination through a collaborative planning, forecasting, and replenishment, documenting best practices and creating guidelines such as collaborative planning, collaborative forecasting, and collaborative replenishment. CPFR in action. Nimble Company exemplifies effective CPFR and simplifying its home entertainment system and supply chain and enhancing responsiveness and reducing costs. With collaboration agreements in place, Nimble receives POS data and sales forecasts from retailers, which help which helps it plan production and share updates with component manufacturers. When demand exceeds expectations, Nimble adjusts its production schedule and negotiates with suppliers. Although one supplier can ramp up production, another offers a suitable substitute with minor design modifications. This collaboration prevents inventory shortage at retailers. The scenario illustrates how real-time data sharing diminishes the bullwhip effect, enabling better production and inventory management. Companies like Walmart, Dell, and Procter and Gamble are leading in collaborative supply chains, sharing sales and inventory data to enhance efficiency and profitability across the board. CPFR in action: a set of practices in which trading partners plan the key supply chain activities to efficiently meet customers' demand at the lowest possible cost. It allows supply chain partners to plan essential supply chain activities to meet customers' demand while reducing costs. How to start supply chain collaboration. To promote collaboration, start by measuring the bullwhip effect in your company over a quarter or a year. Compare incoming customer orders with outgoing supplier orders and graph the divergence. Identify your position in the supply chain, closer to the end customer or further back, as distortions increase further upstream. Many companies overlook the costs associated with the bullwhip effect, often focusing on improving their individual responses to demand fluctuation. Instead, collaborating with other companies to reduce the fluctuation may be more efficient. Once you've quantified the bullwhip effect, estimate its cost, impact on production, transportation, inventory levels, and product availability. Understanding these costs will provide a foundation of discussions on addressing the bullwhip effect. Thi- thi- This effect describing how small fluctuations independent at the retail level.
Information system that support the supply chain. Information technology significantly enhances both internal operations and collaboration within the supply chain. By leveraging high-speed networks and robust databases, companies can share vital data in real time. This ability allows businesses to manage their own positions effectively while also optimizing the overall supply chain. When companies have access to timely and accurate information, they can respond more swiftly to changes in demand, production schedule, and logistics. Information systems serve three primary functions in this context. Number one, data capture and communication. This system collects data from various sources such as sales transaction, inventory levels, and supplier performance. This data is then communicated across the supply chain, ensuring that all stakeholders have access to the same information. Number two, data storage and retrieval. Effective supply chain management requires storing vast amount of data securely and efficiently. Information systems facilitate this by organizing data in databases, making it easy for companies to retrieve information as needed for analysis or decision making. Number three, data manipulation and reporting. Once data is captured and stored, it must be analyzed to extract insight. Information system enable user to manipulate data to generate reports, forecasts, and performance metrics, helping companies make informed decisions. The specific capabilities of this system vary based on the unique needs of each organization and the challenges they face within the supply chain. Data capture and communication. Data capture involves collecting relevant information quickly and accurately. High-speed technologies improve this process by minimizing lag times and ensuring that all parties have access to comprehensive data. This leads to better decision-making and enhances overall efficiency. Data communication refers to how this captured data is shared across various stakeholders in the supply chain. Some of the key technologies that support this, number one, the Internet. The Internet serves as a global data communication network based on Internet protocols. This means that any connected device can communicate regardless of its internal data format. In the past, businesses relied on costly dedicated network for data exchange. Now, the Internet provides quick and inexpensive connections. To enhance security, companies can implement virtual private networks, which create secure channel over the internet. Number two, broadband. The broadband refers to high-speed internet access, significantly faster than traditional dial-up. It remains always on and utilizes technologies like coaxial cables, DSL, and satellite. As, broad, as broadband availability expands, it facilitates real-time data exchange between companies in the supply chain. While many businesses use local area network for internal communication and wide range network to connect multiple locations, broadband allow for efficient, low-cost connection between separate companies, enhancing collaboration. Number three, electronic data interchange. EDI is a technology that enables the electronic transmission of data between businesses. First implemented in the 1980s by large manufacturers and transportation companies. EDI automates essential transactions like purchase orders, invoices, and shipment notices. Initially dependent on expensive mainframe system and value-added network, EDI has evolved to function on various platforms, including personal computers, and can now operate over the internet. Number four, XML or Extensible Markup Language. XML allow for flexible data transmission between computers and human. Unlike EDI, more rigid data format. While various industries are developing XML standards, the electronic sector has made significant advances with RosettaNet. XML and EDI are now converging, allowing for the integration of XML into existing EDI system. This evolution will enable more efficient data translation and support smaller suppliers, promoting flexible communication and improved coordination across the supply chain. Data storage and retrieval. Data storage and retrieval involves how we organize, maintain, and access data within a system, primarily through the use of databases. This is the key component of this process. Number one, relational databases. Relational databases are the most common type of database used in business environment. They organize data into tables where each table represents a specific entity such as customers, products, or orders. Number two, structured query language. This is the standard programming language used to interact with relational databases. SQL allow user to perform a variety of operations such as retrieving specific data, updating records, and managing database structures. Number four, balancing detail and cost. When designing a database, it's essential to model business processes effectively. This involves balancing the level of detail captured against the cost associated with storing and managing that data. Number four, real-time versus batch transaction. Data can be recorded in real time as business event occur or in batches at specified intervals. The choice between these methods depend on the database's design and the specific needs of the organization. Real-time processing is useful for immediate decision making while batch processing can be more efficient for large volumes of data. Number five, tailored views. Databases are designed to meet various user needs through what are known as views. A view is a customized representation of the data that filter and combines information in a way that is relevant to different users.
Data manipulation and reporting in supply chains integrate data capture, communication, and storage with processing logic to support business operation. Like systems are used to streamline and optimize their processes. ERP, Enterprise Resource Planning, integrate business processes like finance and inventory. Example, track and sale and inventory is one system for better decision making. Automates purchasing of supplies. Procurement system automates purchasing of supplies. Example, procurement system automates purchasing of supplies. Example, order more raw materials automatically when stock is low. Advise planning and schedule. Optimize production schedule. Example, adjusting factor output based on current demand forecast. Transportation planning system. Plan and optimize shipping route. Transportation planning system. Plans and optimize shipping routes. Example, chooses the most efficient delivering route to reduce the fuel costs. Demand planning. Forecast customer demand to optimize inventory. Example, use historical data to predict how much of the product will sell. SRM, Customer Relationship Management. Manage customer interactions. Example, store customer purchase history for personalized service. CRM, Customer Relationship Management. Manage customer interactions. Example, stores customer purchase history for personalized service. Sales for automation. SFA, automate sales process. Example, track sales leads and automates follow-up reminders. Supply chain management. SCM, manage the flow of goods and service. Example, track product from supplier to customer inventory management system. Monitor stock levels and orders. Example, alert when products are low and need reordering. Manufacturing Execution System, MES, manage product floor operation. Example, track the real-time status of machine during production. Transportation Schedule System, coordinates delivery schedule. Example, plan track deliveries to multiple locations based on urgency. Warehouse Management System, WMS, control warehouse operation. Example, guide workers on their work story or pick up item in the warehouse.
Assessing technology and system needs. When evaluating supply chain systems, it's essential to keep your primary goal in mind, delivering high quality service and competitive prices to your customers. The technology you choose should enhance your ability to serve customer profitably rather than complicate your operation. This is the key points to consider. Number one, focus on customer service. Your ultimate objective is to provide excellent service. This means ensuring the products are delivered on time in good condition and at a reasonable price. Number two, profitably and efficiency. Success in supply chain management relies on achieving a high level of service while keeping costs low. This balance is crucial for maintaining profitably. Technology should help streamline process, reduce waste, and improve operational efficiency. Number three, simplicity over complexity. Often simple technologies that are used effectively can yield better results than complex systems that are poorly managed. A straightforward system that everyone understands can minimize errors, reduce training time, and facilitate smoother operations. Number 4, management of technology. Regardless of how advanced a system is, its effectiveness ultimately depends on how well it is managed. Team must be trained to use the system effectively, ensuring that they contribute positively to operations rather than becoming a burden.
Executive insight. Since the 1990s, specialized supply chain providers like Diverself have emerged, focusing on specific market. Divers offer order management and real-time supply chain monitoring, priority exception management to handle issues in paced environment. Founder Christopher Martin emphasized customer-driven growth and secure system integration, ensuring customer data is private and used slowly for improvement. Service improvement. Example, Microsoft enhance ordering processing by integrating system for real-time update. For example, in the food industry, they quickly address supply chain issues by managing exception, ensuring timely delivery and minimizing costly errors.
E-business and supply chain integration. The widespread availability of the internet has enabled companies to achieve seamless data sharing across the supply chain. This integration enhances collaboration between businesses, improving their responsiveness to market demands and overall performance. E-business refers to the strategies and practices companies employ to capitalize on this integration. According to Stanford professor Hao Li and Xiujing Wang, e-business encompasses both the planning and execution of supply chain operation through internet-based systems. In their white paper, E-Business and Supply Chain Integration, they outline 4 key dimensions that illustrate the impact of e-business on supply chain integration. Number 1, information integration. This dimension focuses on the seamless exchange of data among supply chain partners. By integrating information systems, companies can access real-time data about inventory levels, order statuses, and customer preferences. This transparency allows for better decision-making and quicker response to changes in demand. Number 2, planning synchronization. The emphasis is on aligning the planning processes of different partners in the supply chain. By using shared forecasting and planning tools, companies can synchronize their production schedule and inventory management, reducing lead times and minimizing stockouts or excess inventory. Number 3, workflow coordination. Effective coordination of workflow among various stakeholders is critical. This involves streamlining processes, ensuring that all parties are aligned in terms of tasks and responsibilities. Improved workflow coordination leads to a more efficient supply chain, as it reduces delays and errors in the order fulfillment process. Number 4, new business models. The integration facilitated by e-business often leads to the development of innovative business models. Companies can explore new ways to deliver value to customers, such as direct-to-consumer sales, subscription services, or collaborative platform.
The experience of the last several years. E-business has evolved in 3 waves. Early online exchange consortium-led purchasing platform, and now integrating supply chain operation for better planning and coordination. For example, automotive companies like Compisin streamline procurement and improve communication across supplier. The chapter summary. The full shift effect in supply chain caused small change in customer demand to lead to large fluctuation upstream, resulting in product shortage and excess supply. Companies often focus on optimizing responses rather than collaboration to reduce this demand fluctuation. Example, for instance, if a slight increase in customer demands for a product leads retailer to overorder from suppliers. This can create excess inventory upstream, actually demand stabilize to combat this, and companies need effective technology system for data management and collaboration.